Welcome to the Snap tutorial video introducing the use of AptPlot within a job stream submission. AptPlot is a 2D plotting tool included with Snap that is designed for creating production-quality plots of numerical data that can read the binary plot files generated by supported analysis codes. This video will focus on introducing AptPlot and defining the key features involved in the creation of plotting data. In the following videos to come, we will provide some examples of how to incorporate AptPlot into a job submission. While this video uses the trace analysis code, the process for generating plots with other codes is very similar. AptPlot is a desktop application that was written to be a drop-in replacement for AC Grace, which is, in turn, the NRC analysis code version of Grace, and was modified to provide direct interfaces to several analysis codes, NRC databank files, and Snap. AptPlot contains extensive scripting and graphical user interface support for the manipulation and analysis of data sets. AptPlot is written entirely with the Java programming language, allowing the application to be vastly more portable than its predecessor. AptPlot is packaged with Snap, which allows the application to share the plot file parsing logic used by the Snap animation module. Let's begin by examining a model with an AptPlot step created in an interactive job stream within Trace. When clicking on the AptPlot step within the interactive view, the property view is populated with its data. The three properties needed to effectively generate a plot are the plot inputs, plot, and plot outputs. The first property is the plot inputs. This dialog is used to define the files that the AptPlot step will use as sources of data. These sources of data could be plot files, NRC databank files, or spreadsheets that will be read by AptPlot to build the plot. Here the user can define multiple inputs using the toolbar, change the input type, and select a file source from the current job stream. The user can also define their input to expect demultiplexed data by enabling the demux option, or enable the plot input to be a file set. The file set property identifies a plot input that represents multiple plot files of the same type to be available for AptPlot. This allows the plot files generated by parametric job steps to be read in at the same time. With our example, the dialog is currently set with a single trace XTV file set as the plot input. Next, we have the plots dialog. This dialog allows adding and editing plots, graphs, datasets, and annotations. At the root level of the tree are the plots to be generated. Each plot is a unique canvas upon which a graph will be drawn. Consider this to be a single page or image to be generated. Each plot is able to contain any number of graphs defined by the user. A graph is a visual display of data read in from an input file and consists of datasets and annotations. Datasets are XY pairs read in from a data file that are drawn as points or a line in the graph. Annotations can include rectangles, ellipses, lines, and blocks of text used to add additional visual elements to a graph. Each dataset definition in a graph describes a set of independent and dependent data extracted from an input source. Dataset definitions have the following properties. First, we have an input source that defines a reference to the input from which this dataset definition reads data. A plot type that defines the type of data read into the set. Various properties are enabled depending on what the plot type is set to. Available options include time, time point, parametric, parametric point, and axial. Time indicates that only the dependent data will be specified. The problem time channel will be retrieved automatically and used as the independent data. Time point is specified in much the same way as time, except that instead of plotting the entire problem time, it retrieves a single value at the specified time. Parametric allows specifying the source of both independent and dependent data. Parametric point is specified in much the same way as parametric, with a single point extracted from the combined data at a specified time. Independent data and type are provided for parametric and parametric point datasets. The independent type determines whether independent data specifies a single channel or a complex expression. When the independent type is set to expression, the independent data is interpreted as an AptPlot equation interpreter expression, but with one distinction. Data channel names must be surrounded by curly braces. To use the braces within an expression, use the \escape character. The time property specifies the time at which time point, parametric point, and axial type datasets are based. Next, we have the dependent data and type available for time, time point, and axial. The dependent type is similar to the independent type for the dependent portion of the dataset. When building an axial plot, the dependent data must include a wildcard to indicate how the axial mesh index should be incorporated into the channel name. This will be explained more in the axial plot example. The axial locations define the axial or z direction locations for a series of mesh locations in a single component along the direction of flow for the data channel being plotted. Some codes like trace support automatic identification of axial locations for plotting. Additionally, cut, copy, and paste actions are available on the right side of the toolbar. All of these actions are also available from the right-click pop-up menu of the various entries are in the tree. Finally, we have the plot output dialog. This dialog is responsible for various types of outputs produced by the AptPlot run. Each output definition results in an output on the AptPlot step. Output definitions can be added, removed, and reordered using the toolbar buttons provided within the dialog. Here the user can change the output type, change the plot associated with the output, and set a predefined external file that is connected to the AptPlot step. These output files are available within the defined directory for the job submission and can either be accessed locally through the user's file system or by going to the job submission interface and navigating to the desired submission's output files. Thanks for watching. In the next video, we'll walk through some examples of how to use AptPlot within a job submission.